Solving systems of equation is something you did way back in the day in Algebra 1, but we're going to dial it up, of course, in Algebra 2. So the first method is solving systems of equations by graphing. So we're quickly going to review the three forms that we've graphed in: slope-intercept form, standard form, and point-slope form. So slope-intercept is probably the one you're most familiar with, the y equals mx plus b. You start with your y-intercept, the b, and then you use your slope, your m, to move to your next point. So if we look at y equals negative 2/5 x plus 7, the 7 is the y-intercept. It's the number without the x. Y-axis is up and down, so it's crossing at a positive 7, that would be there. Then you use your slope to move to the next point. If our slope is negative, we're going to go down in height. So we're going to go down to right 5. We can either use a ruler or you can keep going down to right 5. You could backtrack it and go up to left 5, but that would be our line. Now you want to make sure with systems of equations, because we're going to graph two lines on the same graph and see where they cross. So you want to make sure your lines are extra straight. So use a ruler, use the end of a book, or keep doing the rise over run to find your next points. So slope-intercept form, probably the easiest. Standard form, a little tougher. It's when you have the x and y on the same side. So what we do is we substitute in 0 for x, but 0 times anything is 0. So basically cover up the x part of the equation and you write what's left. If I did that here, we'd have negative 6y equals negative 12. We're also going to do the same thing with the y's. We cover those up and we're left with 4x equals negative 12. We're going to solve both of these equations and they will give us the x and y intercept. So 4x equals 12, we'll divide by 4. We get x equals negative 3. Our x-intercept is negative 3. The x-axis is the flat one. We're at negative 3, that's 3 to the left. For the y's, we'll divide by negative 6. Negative 12 divided by negative 6 is 2. So the y-intercept is positive 2, that's there. Again, if you're using a ruler, that's no problem. I can't use a ruler up here. So if I just count my rise over run, it's up 2, right 3. I can keep that going. Up 2, right 3, up 2, right 3, up 2, right 3. You could go down to left 3. There we go. So again, kind of a trickier one. I think slope-intercept form is easier. You could turn that into slope-intercept form by getting y by itself. So you can subtract 4x to the other side. So we'd have negative 6y equals negative 4x minus 12. And then you just divide everything by negative 6. That would give you y equals, this fraction would simplify to 2/3. And then negative 12 divided by negative 6 is positive 2. So then you'd start at 2. And our slope's 2/3, you'd go up 2 over 3. It gives you the same line. It's just a matter of which work do you want to do there. And the last one, point-slope form, is this sloppy thing. It tells you a point and it tells you a slope. So the point, the coordinate, comes from what's grouped with the x and what's grouped with the y. Now for the x, it says x plus 1. When we're bringing out our coordinate, it comes out as the opposite, because the original formula has subtraction in it, so it's like opposite of. The y plus 3 means our y coordinate would be negative 3. So there's our point of point-slope, and the slope is the negative 4, which if we're thinking of it like a fraction, would be negative 4 over 1. So we go to the point, negative 1, negative 3. There's our first point. You just need 2 to make a straight line. And then we'll use our slope. We'll go down 4, right 1. Down 4, right 1. Could go up 4, left 1. There you go. So we've seen all three forms. So we're going to graph 6 systems of equations, and we're going to find their point of intersection. The coordinate where they intersect would be the only x and y that work for both equations. Y equals negative 1/3 x plus 5. Y equals x plus 9. We're graphing them, and we're finding where they intersect each other. And that's our solution, that coordinate. So negative 1/3 x plus 5, you'd start at 5. And then your slope's negative 1/3, so you go down 1, right 3. Do that a few times, or just use a straight ruler, you could go up 1, left 3 as well. I think I counted correctly. Alright, the second one, y equals x plus 9. The y-intercept is 9, and the slope is in front of that x, that's a 1. So we'd go up 1, right 1. Now, they're obviously going to cross over here, so we could go down 1, left 1, until we find where they cross. So this is the super important coordinate for us, which is, it's to the left 3, so that would make the x negative 3, and it's up 6. So the coordinate would be negative 3, 6. You can substitute that into both equations for x and y, and they both work. That's the only combination that will work for both equations. So that's what we're trying to find here. So let's try some more. Y equals 2x plus 1. We start at 1. Our slope's 2, so it's up 2, right 1. We go down 2, left 1 as well. So our first equation. Second one, negative 1/2 x plus 6. You start at 6. Your slope's negative 1/2. That's down 1, right 2, which is where they cross each other. That's the important coordinate for us, and that coordinate is 2, 5. And it works for both equations. 2 times 2 is 4, plus 1 is 5. It works. Works in the other one too. Negative 2x plus 8. We start at 8. Our slope's negative 2, down 2 over 1, down 2 over 1, down 2 over 1. There's a lot on this one. We go up 2, left 1 as well. Alright, y equals 3/4 x minus 3. Start at negative 3. You go up 3 over 4, which is where they cross. Up 3 over 4. Oh my gosh, let's pretend like I drew a straight line there. They cross right there at 4, 0. So that would be our solution. And it works for both equations there. Now, of course, there are some special scenarios that we do have to keep in mind. So we have one more normal one, and then we got some goofy ones. The first one, 2x plus 3. Start at 3. Slope's 2, so you go up 2 over 1. Could go down 2, left 1. Fun. The other one is point slope form. So getting the coordinate out of that, it says x minus 2, so our x is 2. It says y plus 8, so our y is negative 8. So 2 negative 8 would be down here. And then our slope is negative 3, or negative 3 over 1. So we go down 3, right 1. Now, it's not going to cross down there, so we're going to have to backtrack. We're going to go up 3, left 1, up 3, left 1, up 3, left 1. There's where they cross. Up 3, left 1. So that coordinate is negative 1, 1. Great. Alright, look at number 5. Negative 1/5 x plus 6. Start at 6. Our slope is negative 1/5. Down 1 over 5. Down 1 over 5. We go up 1, left 5 a couple times as well. Second one, negative 1/5 x minus 1. Starts at negative 1. Our slope is negative 1/5. Down 1, right 5. Down 1, right 5. Could go up 1, left 5. We're looking for where these intersect each other. These are never going to cross each other. These are parallel lines, and you can tell that because they have the same slope but different y-intercepts. They'll never cross. Our solutions are where do they cross, and it never happens. So if that's the case, you write no solution. There is another goofy one on number 6. 2/3 x plus 1, you start at 1. Our slope is 2/3. Go down to left 3. The second one's in standard form, so you could set up two equations, negative 2x equals 3, 3y equals 3, solve each of those. Divide by negative 2, x is negative 1.5, over here y is 1. It becomes the exact same line. If you were to rearrange this and get it into slope-intercept form, it's the exact same equation. So if they perfectly overlap each other, we use IMX, which means infinitely many solutions. Because there are infinite little decimal intersections here. It's the same line. So any place on the line of one of them is going to be on the line of another. So IMS, infinitely many solutions.